Hi, as my chemistry summative for year 2010 to 2011, I've decided to do research and make video on how acids and bases are used in our everyday life. What is an acid? An acid can be defined as a substance which reacts with a base. Acids can be identified as tasting sour reacting with metals. Since the slime contains citric acid, it should be sour. And I'll be tasting this lime, which you can see it is really juicy if it is actually sour. Here we go. And in conclusion, it is really sour. What is a base? A base can be defined as a substance that reacts with an acid. Some characteristics of base are it has a slippery feel to it and it tastes bitter. There are three common definitions for acid and base. First one is Arrhenius definition. Second one, Bornstedt-Lowry definition. Third one, Lewis definition. This fine gentleman here is Mr. Arrhenius, aka Jenny Lee's boyfriend. This man defined an acid as a substance which increases the concentration of hydrogen ions, H3O+, in a solution. The man on the left is Johannes Nicholas Bornstedt, and the man on the right is Thomas Martin Lowry. These two men in 1923 expanded on Arrhenius' definition of an acid. They said that an acid is a substance which can act as proton donor, and the base is a proton receiver. This is an example of pH chart. Neutral is considered neutral because that's the pH of water. Acid is a concentration of H+ ions in a solution. When you take the negative base 10 logarithm of concentration of H+ ions in the solution of pure H2O, you get 7. An acid is a chemical that gives up H+ ions. When you take the negative logarithm of the concentration of H+ ions of an acid, you get a number less than 7. A base is the opposite, something that absorbs H+ ions. Thus, the negative logarithm of a base comes out to 7. When something is called an acid, the pH number is less than 7, and when something is called a base or alkaline, the number of pH is higher than 7. The generally accepted maximum and minimum number for acid and bases is 0 to 14, although in extreme cases the numbers can be lower or higher than 0 to 14. Now, since we know the definition of an acid and base, the basic characteristics of an acid and base, the way to differentiate the acid and base by using pH chart, since we have all the basic information that we need, I will now introduce you to some acid and bases that we use in our daily lives. First of all, I will introduce you to HCl, hydrochloric acid. This solution consists of hydrogen chloride, and it is mixed as a solution in water. Hydrochloric acid should be handled with care because it is highly corrosive and it is highly dangerous when exposed to the air. HCl is required in many industries, for example, manufacturing of fertilizers, treatment of cotton balls, cleaning these old oxidized pennies into making it look like a new penny. HCl, hydrochloric acid, is also used largely in small applications such as leather processing, purification of common salt, in building constructions, and house cleaning. Even in the oil industry, HCl is widely used. Sometimes in the North Sea, when a rock is covering the oil well, HCl is injected to degrade the rock, creating an opening for the machineries to work. This enables the machineries to go down and extract the oil faster and safely without using any human effort. Now, since you got to know about HCl well, I will move on to explain about lactic acids. What is a lactic acid? The lactic acid is also known as milk acid, and its molecular formula is 3H6O3. And when this acid loses a proton, it is turned into a lactate. This lactic acid, same as HCl, it is present in our bodies. During power exercises such as sprinting, when the rate of demand for energy is high, lactate is produced and is found in muscles. Also in foods, lactic acid is found primarily in sour milk products such as kombucha, laban, yogurt, kefir, and some cottage cheese. The casein in fermented milk curdled by lactic acid. Lactic acid is also responsible for the sour flavor of sourdough breads. This acid is also used in beer brewing to lower the pH and increase the body of water. Now, I will introduce you to hydrofluoric acid. Hydrofluoric acid is a solution of hydrogen fluoride in water. There are several industrial uses for HF, hydrofluoric acids, such as oil refining, production of organofluorine compounds, production of fluorides, making etchants, and cleaning agents. The ability of hydrofluoric acid to dissolve metal oxide is the basis of several applications. It removes oxide impurities from stainless steel. This process is called pickling, and silicon wrappers in the semiconductor industry. It is also widely used as a precursor for many medicine. Hydrofluoric acid gel is also commonly used to etch all ceramic dental restorations to improve the bonding, and it is also used to etch glass. Sodium hydroxide, NaOH, also known as lye, and casting oil, is casting metal base. It is used in many industries, mostly as a strong chemical base in the manufacturing of pulp and paper, textiles, drinking water, soaps, detergents, and as drain cleaner. Worldwide production in 2004 was approximately 60 million tons, while demand was only 51 million tons. Pure sodium hydroxide is a white solid available in pellets, flakes, granules, and has 50% saturated solution. Sodium hydroxide is frequently used as an industrial cleaning agent, where it is often called caustic. It is added to water, heated, and then used to clean the processed equipment, storage tanks, and etc. It can dissolve grease, oils, fats, and proteins based on deposits. The sodium hydroxide solution can also be added to surfactants to stabilize dissolved substance to prevent redeposition. A sodium hydroxide solution is used as a powerful degreaser on stainless and glass bakeware. It is also a common ingredient in oven cleaners.